Welcome. It's Sunday. In this episode, I had a viewer commenting that he couldn't find this board. This is the new QTPy ESP32S2, and this particular one is brand new. So I just got it myself. So I'm going to show you how in Visual Studio Code to fix this problem. But first, when we plug this board in, and I'll just flip over to a console and I'll show you. So our friend D-message is going to show that we've disconnected something. Now we're going to connect this guy up. And you can see here one ESP32S2 QTPy. But no CircuitPy drive yet. Now if you get this scenario on brand new boards from Adafruit, it's probably because they have the demo UEF2 firmware in there. They don't actually have the correct one yet. So what we're going to do is on this board there's a reset button, and if we hit it twice we should get an RPI drive in a moment. Let's see if we get it. Timing is a bit critical on this. So this CircuitPy here doesn't belong. It belongs to the macro pad. So let's try this again. There we go. QTPy S2 boot. Okay. So we're going to mount this guy. And then up here, we are going to go to that directory. So this current UF2 that you see in here is actually technically not the full one. It's designed to demo the board. So we're going to delete it, and we're going to go over here to, let's say, search. It doesn't really matter. I just need another directory. So I'll go into work, into my controllers, and I happen to have the ESP32 QTPy right here. Here is the actual 711. So we'll copy this, and we'll come here and we'll paste it. So you can see blinky, 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 lots of fast blinks. Those are the data receive and send. It's busy being dumped. Okay, the copying is finished. In a moment, we should get a prompt for about a CircuitPy drive. The second CircuitPy drive on my system. Yes, this one. So we'll mount this. And we will go have a looky at it. So this is empty. You can see there's no VS Code stuff in here. There's nothing. So this unit is ready now to receive, be used in Visual Studio Code. But the problem was that in Visual Studio Code, and I've already fixed my Visual Studio Code, but in the board picking list, after you open this folder up, this wasn't in the list. So we are going to fix this. We're just going to pretend it's not in Visual Studio Code at the moment. So what you need to do is we're going to need, first of all, and let me just scroll this a little bigger here. I have a working area I call my problem area. This is just for dealing with this. So there's the VS Code CircuitPython directory. You're going to need to go get it. So it's going to be like this. You're going to git clone that directory. When you're done, you're going to end up with this. So if we go into here, okay, now I'm going to rm-rf the boards, because I already built it, the stubs, and the CircuitPython directories there. So this is what you'll get if you haven't done anything yet. It's all empty. Okay, so we go into the scripts directory. You're going to find a bunch of scripts. There's a Windows script that's CMD. There's a JavaScript bindings one. There is a, we don't worry about it. All we care about is the shell script. Now, by default, the shell script doesn't work. I've been meaning to put a bug report in and have them fix this. So they did clean up this script from the previous a while back version. This is a lot cleaner. But basically the script comes along. It clones the CircuitPython Git. Gets some stuff inside those submodule stuff. But this part here, this virtual environment, I don't know what they're trying to do with it. I understand what it's for. It's supposed to contain like a container which you do all your work in. This isolated from your regular stuff, but it doesn't work. They need to look at that. Now the other problem here is this line right here. They have the path as docs/requirements.txt. That doesn't exist. So I had to correct it to, because the requirements.txt is one back from this directory. So requirements.txt. Okay. Then the rest is fine. This builds the stubs. Okay. And the last little piece here, they would rm stub/board. Okay. I didn't. I left it alone. And then they would, of course, deactivate the virtual environment. I'm not using it, so I remmed it out. Okay. So we run the script. It's set for executable by default, so you should be able to run it. It goes off and gets the CircuitPython stuff, the submodule stuff. It checks some requirements. It builds the stubs, gets the boards, doink. Okay. Now, the way this works is the boards is the pins of the boards. So boards tells where all our pins are on different microcontrollers. Stubs, on the other hand, tell us the built-in modules that are inside the UF2. So when you code in Python, you can include a .py file, for example, import something.py, or you can import from the lib directory, and in that lib directory it could be either an MPY file, a compression file with stuff in it, or a PY file, or you're importing those stubs. So when you say import boards, for example, in your code, you will never find that file because that ACK file is actually in the UF2 file. So what we've done here is we built the boards and stubs. Now if we go back one directory and we have a look, there's boards right there. There's stubs right there. So what you want to do with this is, usually the first thing I do is in this extensions directory here, I move the boards out of the way and the stubs directory out of the way. And then I come back here and I just copy. So I'll flag boards and I'll flag stubs and I will copy it back over here to, we find Mr. VS Code, extensions, whoops, and we find Mr. Joe here, there we go, and I put the copy there, which is already done. Okay, once you've done that and you've copied the new boards and the new stubs, you can now come back to here, right, and we're going to open a folder and we're going to open the CircuitPy. As you can see, there's nothing in there. We'll say OK. We'll give it a moment to settle down. It's going to go here and choose the bundle and everything else. What it's really doing is initializing the settings JSON for the first time. This. So you can see 711, Pylance, blah, 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 all set up. Okay. Now, I'll go over here to choose a board. And I can search Qt. And there we go. QtPy ESP32S2 now shows up. Okay. If we look at the settings.json after I click this again, more stuff is put in here. So you see the reference here to these numbers. These numbers correspond to the vendor and product IDs when you plug the USB in. Okay. And you can see this stuff. Okay. Now the only problem I have with the settings.json file is sometimes these dates don't get updated properly. So if the bundle updates tomorrow, let's say to 0129, this will still be 0128 and you get a yellow thing. You just have to either erase this file and have it recreated again, or just edit the date in here. Now, since I've want to save this a more permanent, I'm going to create a workspace file for this. Here we go, one workspace, and I'll call this qt-pi-esp. Let's see if I can type esp 32-s2, like so. And I'm going to make sure I'm doing it in the CircuitPy directory, not in the VS Code directory. There we go. Now, from my understanding of some of this, this has a tendency to override the settings.json file. This is more global. But we are all ready to go. So we can look at code. There's hello world. Yeah, whoopee. So let's find a Blink program for QtPy. I think a standard Python Blink program should work. Not a Blink INO. We need a code. Not that one. Do we have one in here? Doink, doink. No, it doesn't look like I have one available. Okay, so what we're going to do, I'm just going to go visit this, the how-to page for this. So we're looking for QtPy ESP. Yeah, that's it. Yeah. So this particular one has the antenna on it, and there's one with the built-in, but they're basically the same boards. So I'm going to go down here to where they have primary guide. Here. This is what I'm looking at. So all I want out of the primary guide is CircuitPython Essentials, Blink. There's the Blink program. We'll copy the code. We'll come over here. There's our code. Now, the only thing I've ever noticed on these is, wow, this is a very slow blink, by the way. Is that, let's change the sleep here to 0.1. Here, I don't think the blink is actually working properly. I would have to debug and find out what. I don't think the code's quite right. So they're filling with one light here. I mean, if you go like this, we can test this 255. That changes the other pixel. But you get the idea. So now that I've got a newer boards and the newer parts will show up in here. Okay. Now what's not in here yet, and I believe if you watch Deep Dive with Scott, the S3s aren't in here yet. So there are those little boards that are the S3 boards. I don't have them over here. I have them actually over there. But they're the ESP32-S3 boards, various ones. You'll find that they're not ready yet with CircuitPython. They're working on it. And the other one I haven't tried out yet, and I need to do it, is putting CircuitPython on here. No, on here. I mean on regular Raspberry Pi stuff. So I have like some Raspberry Pi Zeros and stuff like that, and there's that bare metal CircuitPython you can put on there. Yeah, this is really sucky. This LED is not doing what it's supposed to be doing. It is flashing the NeoPixel that it's on here. It's a very tiny NeoPixel. But I don't think it's flashing the right color, and it's taking way too long. So I would have to look at this. But that's the idea. Now that the board structure has been updated when you have new boards. I'm going to close this workspace, and then I'm going to remove the CircuitPy drive. Safely remove. Okay, boink. Now, I did have on my last video this. I thought I'd give you a little update. So this was that Mega 2560 Pro. Well, I had two of them. This one doesn't work, and I've marked it. Sure, it powers out, lights are home, but you can't seem to program it. This one, on the other hand, does work. Not with that connector, of course. This is older USB. Like so. So this is Arduino code at the moment, so not CircuitPython code. So let's go open file, and we need to go to work, or projects actually, and Arduino, and downstairs I believe I had, yeah, Mega 250 Pro, and open. There's a workspace file there, so let us actually open the workspace file. Projects, Arduino, Pro, workspace file, open. Here we go. So what I found out with this one is on the web page for this, if you actually have to look this up, see if I have the pages open on it. If we go here and you go like this, oops, wrong one. Let me find the other Chrome here. Properties. We need the other Chrome. Just Google, eh? Yeah, okay. Okay. If you go to Platform IO, we need to look up all the boards, because this is the issue I had with this, is figuring out which board this was. So we go to boards, and I narrowed it down here to just Arduino frameworks, and then I searched in here Mega 256, Mega 2560 Pro. Okay. And came to this. Whoops, not that. That's the platform. Is it right? Yeah, here. And then boards. So here's the master list of all the Arduino. I changed this to show 1,000 so I could go. Now, if I do a web search and say 2560, you see there's 17 hits for this. So I tried this one, for example. Technically, this is what this is. Right? Didn't work. I then tried this one here. Slightly different thing is 254 kilobytes of cache instead of 256. Didn't work. Then I came down to these guys. Okay. This first one here, Controller Maxia. Right? You can see it's slightly different on the stuff. But this one was the one that actually worked. So I kept changing the board piece in here. Moving it forward. So now if I go here and I do a trash can on platform to clearing everything out, and I'll just make this bigger, and then we do a compile, no problem, and then we do a push, no problem. Everything pushes properly. And if we open, of course, up our source main CPP, and we have the standard Blink program in here. If I change this to, and we look at it, let's see. We change that to, let's say, 500. Save it. Then we come down here and we'll push another copy in. Now we change the blink rates. So this one's working. Okay. But if I plug the other one in here, this one, that one, I mean, it looks like everything is working. If I push to it, it gets stuck doing it. Now I can check the D-message log and see if it's still USB 0, and it is right there on the thing. It is USB 0. So it's not correct. So this is what happens. This is not, it's timing out. So this one here is not working. Something is wrong in there. Don't know what's going wrong. As far as I can tell, there's nothing, no bad traces, no anything. I do see one unsoldered pin, but that doesn't really count. There literally is nothing on here that looks like it's out of place. They look identical, but this one doesn't work. And this one does. So this one's good. Now, it apparently has almost the same amount of pins and stuff. I think maybe a little more than a classical Arduino Mega. So, but that's my status update for that. And for the CircuitPython stuff. So if you can't find your board, how to rebuild the board stuff for it in the extension. And then you should be okay again until, well, more boards show up. And they're all constantly coming up. So that is it for the moment. I will call it here, and I hope this helps people.